of mathematics performance of WASSE from 2014 to 2017. In fact, he focused on core maths, but for some very good reason, I will look at 2017 core maths and again 2017 elective maths as I go along. But as a way of introduction, since the ISSER and the WASSE began in 1993 up to 1998, that was when ISSER ended. Then in 1999, WASSE began and they still continue. In fact, there have been a phenomenal increase of candidates from over 4,000, just a little over 4,000, to 27,000. That's about 551% increase since the ISSER and WASSE began. One would have expected that there should have been corresponding performance in that regard, but it has not been so. Ghana is still struggling over 40%. Now looking at the trend, if we look at core maths 2014, the total number, the number of schools, and what I use is, I use the PISA model. Now with the PISA model, we weight the scores. That is grade A is 10, grade B, that is B2, is 8, B3 is 7, and C4 is 6, C5 is 5.5, C6 is 5. So looking at the PISA standard, and when I talk about PISA, I mean Program for International Students Assessment. Ghana is way below the PISA standards. And that is worrying. 2014, the mean 2.19 over 10. Way below the PISA standards. 2015, it even went down 1.52. 2016, it peaked a little, 2.16. And then 2017, 2.98. I have been using the median score. Those who are very well versed in statistics shows that if you use the median score, then you are able to adjust for outliers. So when we look at the median score, it is still not the best. Surprisingly, some schools are doing well. In 2014, a school scored 9.13 over 10. And that was the highest school, the highest score. In 2015, the highest score was 7.05. 2016, 8.95. In 2017, there was a drop, that is 8.25. If we look at the corresponding minimum, it is very serious. And majority of the schools are scoring close to 1. And that is very serious that we need to look at. Now we try to look at it region by region. 2014, the region that topped was Brong-Ahafo, followed by Ashanti, then Western. Many people are asking, why not Central? Sometimes we think that we tag Central with Cape Coast. There are some schools in Cape Coast that are doing very well, but there are equally many schools in Central region that are not doing well. So the schools in Central region that are not doing well are pulling down the few schools in Cape Coast. That should tell us that we must not only be concerned with the schools that are doing well, but we have to be concerned equally with the schools that are not doing well. Because in life, you don't only accentuate your positives, but you have to mitigate your negatives.
Please repeat that. Repeat, please. This is very powerful.
What I'm saying is that
Repeat, please.
we should not be concerned with always encouraging the schools that are doing well. It's good to do that. But we must find ways and means of bringing up the schools that are underperforming to come up. Otherwise, the achievement gap in Ghana will continue to widen. And when followed by Ashanti, Western, Central, Eastern. That is 16. Let's look at 15. Yes. Wrong at top, Ashanti, Western, Central. You see that there are 4 regions that are consistently underperforming. And these regions are Northern region, Volta region, Upper East, and Upper West. And that is a worry. It's a worry in terms of human capital development. 2016, the picture is the same. We still have Brong-Ahafo, Ashanti, Western, Central, Eastern, Greater Accra, and this time Upper West came up a little, but not as much as the others. Ashanti, then Eastern, Central, then as you can see, Volta, Upper East, Northern, and Upper West are trailing. Now, this is the pass rate. This is what the ministry have been using. What the ministry have been using is to have A1 to C6, and that is the pass rate. The picture is the same. Now, this is the students, the candidate, the number of candidates that sat for the elective mass. You can see the Ashanti region presented the highest number of candidates compared with other regions. But when it comes to performance, the picture is different. Brong-Ahafo, followed by Central, followed by Greater Accra, followed by Eastern, in that order. Then they waited. When we waited, you see that the picture, some of the regions has come up. That is why I have been using the weighting instead of the percentage. The weighting, Brong-Ahafo, Central, Greater Accra, and again Volta, Upper East, Upper West are straight. Now, I also look at the proportion of grade A. This is the proportion of grade A. That should be correct. This is the proportion of grade A. In that regard, Central top. And this is not surprising because there are schools in Central region like Western Girls, Augustines, that did very well in getting a number of grade A's. Now, looking at the proportion of students who have F9, You can see it for yourself. Volta, Northern, Upper East, Upper West taught. So you can see that there's a gap between these and the others. That has to be closed. Thank you very much, and God bless you all.
You are the math teachers. And so if this is a picture that we have, who is responsible for this? We. Oh, repeat it. Let me repeat. You are the math teachers. That's what we are. And you are. You see how Lord is slowly away. If we cannot do something about it, then who will? And where are we going to look for to find somebody to help Ghana? Now I want to say also that other nations have done this. When we hear about Singapore and we hear about Indonesia, other nations have done this. And we have had Ghanaians who have gone all over the world and succeeded at the very highest level. There is nothing wrong mentally with us. Let me repeat, there is nothing wrong mentally with us. But we have to look at the figures, and every one of us here bear responsibility, myself included, in those figures. And every one of us here bear a responsibility in changing those figures. Now, is it possible? Is it possible that a group here, such as you, wonderfully talented, can change the trajectory of this nation? That is the question that I'm posing. Is it possible that this team here, this group here, will begin to change the trajectory of this nation? Oh, come on, listen to what you are saying. So. Is it possible? Yes. Possible. And so, in order for us to begin, it is possible. It is possible. We are brilliant. We are talented. You here have something. You've been given a gift from God that requires you to give it to somebody else. And so, why are we here? We are here to talk to each other and to learn and to see how best we can change this thing. It may not happen in my lifetime, but surely it will happen in your lifetimes. All right. So, with that said, I had a hand go up, and I want to
Thank you, sir. I was sincere. I was going to say that we've seen a presentation of the level of failure and passes, but it goes beyond what we are seeing here. We are looking at the Ghanaian system where our students are examined by examination body, WAEC, the syllabus, the content. You see, they are passing the elective maths. Why are they passing the elective maths more than the core maths? Have you observed that? Now, the structure of the elective maths and that of the core are not the same. Now, in certain parts of the world, the examination, students are not tagged to fail. Our system of examination here, at the time, as if we are targeting some people to fail. out there, they are calibrated. And so sometimes it becomes as if the teacher. Yes, the teacher has a part to play, but in totality, there are other aspects that I want us to have a look at. Okay. Thank you.
I think I very much agree with him. Please, let's give him a very big hand of applause. Okay. Because what I heard him saying was that there are some other factors. Maybe it's the syllabus. Maybe it's this. Maybe it's that. I heard him say that. But then also what I am hearing myself saying is that we have a problem. And unless we begin to say we have a problem that we have to stamp out. When you see a snake, you don't begin to say that, well, this is a snake, but maybe, it's the type of lizard, and so you want to do. What do? You stamp it out. And we have a similar problem. And so with that much said, let us begin to ask ourselves, what can we do?
And so I'm not going to talk too much. In fact, I think that to get what CEMATHS is about, to a large extent, you have to experience it. And since CEMATHS is essentially the transportation, I don't want to use that word, the adaptation of Math Core in the Ghanaian context, it would make sense to get an understanding of what Math Core is all about. And Mr. Bourne, I have a hard time calling him Mr. Bourne. I'm trying.
Holy, worshipful master.
Holy worship, yeah, I'm not going there. So Mr. Bourne tried to talk a little bit about what Math Core is about, but the person to do that is Mr. Darrell Gardner Jr. So let's have Darrell come up.
Good afternoon, everyone. Okay, good evening, everyone, again. My name is Darrell Gardner. I bring you greetings from the United States of America, Wayne State University. I serve as a director in the Department of Mathematics. I direct the Honors Mathematics program as well as the Developmental Mathematics program. But the most meaningful work and the most meaningful role, can you hear me? Okay, can you hear me now? We're good? Okay. But my most meaningful role is that of Dean of Students for a program called the Math Core. So you'll be getting different perspectives. There are a few of us here throughout the week. You'll be getting different perspectives and aspects of the program. Today, what I want to present to you, because you all are mathematics teachers, are 10 principles of teaching mathematics. And I'll be introducing some of the concepts and ideals of our Math Core curriculum. So why are we here? As Mr. Salamat pointed out, that there is a crisis in mathematics education. It's not just a problem here in Ghana, it's also a problem in the United States and all around the world. It's a global crisis. One of the reasons for the crisis, and this is a different conversation for a different day, is standardized testing. We put our children in high-stakes testing environments and expect for them to perform. And their entire life trajectory is based upon one day out of 1 year, and that could literally choose the path of life for them. It's unfair, and that's a separate fight that we must also fight. But issues in mathematics education, including phobia, which we're addressing at this conference, is not about the kids, nor is it about you guys as teachers. I humbly submit to you that it's about the way that we teach and the way that we expect for kids to learn mathematics. Our curriculum oftentimes is not coherent, nor is it cohesive. So the Wayne State University Math Corps, we've been around for about 25 years, and we're a combined enrichment and mentoring program. We service kids from 7th grade through 12th grade, and college students serve as mentors to those kids. We have a significant amount of success over the course of 25 years. Again, I'll be introducing you guys to some of the curricular elements, and my esteemed colleague will show you some of the cool things that we do. I'm just going to grab some water really quick. We give kids the essentials that they need to be successful in their current coursework, which is the broccoli. And then the ice cream, we introduce them to higher level mathematics. It's not uncommon to walk into Mr. Bohm's classroom and see 7th grade children doing calculus. You'll get a demonstration of that today and tomorrow. All right, 10 principles of teaching mathematics. So if you have a notebook or something, I do strongly encourage that you write some of this down. I will make the presentation available to anyone who wants it. I'll send it to the conference organizers and make sure that you all get a copy of this presentation. Principle number 1. Give a preview of what to expect. How many people go to see movies without looking at a trailer or a preview? You at least need to know what you're going to expect. So if you're teaching algebra, you shouldn't walk in putting equations and formulas on the board. You need to give them a preview of what the subject is all about. Do I have a brave soul that wants to define what algebra is? How you define algebra? Anyone? No one? Yes, sir.
It can be explained as using letters to stand for numbers, in short.
Okay, anyone else?
Algebra can be defined as the use of letters and numbers to solve problems, mathematical problems.
Okay. One more.
Algebra is an expression that deals with letters and numbers.
Okay. Couple more.
Algebra is a mathematical statement involving numbers, variables, and any of the mathematical signs.
Okay, one more.
Algebra makes use of expressions that uses either symbols or letters to represent numbers, or nouns, or unknown.
Okay, all right. So, about 6 different answers, right? That's a problem. We do not have a universal definition for the subjects that we're teaching, so therefore we're going to have a universal problem. Secondly, and thank you guys, let's give a hand clap for those who participated, by the way. Secondly, there's nothing to be excited about in those definitions. It just sounds like something that I have to do that I probably don't want to do because I was never good at arithmetic. And so now you're going to introduce some letters? Wait a minute, what? I thought this was mathematics. In our curriculum, we simply define algebra as the study of operations on the real numbers. Kids know what operations are, and they should know what the real number system is by the time they get there. So imagine you walk into a classroom. All right, guys, get ready for a strange tale about operations on the real numbers. They probably would leave if it goes something like that. But you want to make it exciting for your kids. Give them a sneak preview as to what this thing is about, but relate it to things they already have mastered. It takes all of the intimidation away. Principle number 2, start at the start. Start at the start. You must build a solid foundation. You must emphasize a strong foundation when teaching mathematics. What happens if you build a house on a pile of sticks? It's going to collapse. You have to make sure that their foundation is rock solid. Because what happens is that any hole or gap in their mathematical understanding, that as they move up, that hole will get bigger and bigger and bigger and bigger, and it'll be virtually impossible in a traditional classroom setting without programs like the Math Corps to catch up. And you find so many children with so much promise, with so much brilliance, with so much greatness inside of them that don't ever get that opportunity because their foundation was never strengthened. Principle number 3, be sequential. Sounds like common sense, but oftentimes in most math texts, we tend to bounce around and do different things depending on your statewide or in the U.S. we have statewide standards that we must follow. Those aren't always sequential. But if a kid doesn't have number sense, if a kid doesn't know if 2/3 is, which is bigger, 2/3 or 4/7, why would I ask them to add the two numbers? Right? They have to have a strong understanding of the number system before we ask them to do anything. Does that make sense? Mastery is key. You cannot rush the process. I understand as math teachers, you don't have a lot of time in your day. But there's after school, there's homework packets, there's parent programs that you can create, there's summer enrichment programs that you can create. This thing takes commitment. Principle number 4, keep it mathematical. Fractions are not slices of pie. They are numbers. We only use real-world applications to provide relevancy to the subject that we're teaching. Mathematics is applied across all disciplines. Never describe anything mathematical as something non-mathematical. It will confuse your kids forever. Principle number 5. This one is a little touchy because we all learn mathematics probably this way with lots of shortcuts and lots of tricks. For example, I have up here, this is a famous one in the States. I don't know how famous it is. When you're multiplying 2 by 2 binomials, they call it FOIL. You multiply the first terms, then the outer terms, then the inner terms, then the last terms. Well, it doesn't work as soon as you add another term to either one of the expressions. Or what about this one? A number is divisible by 3 if the sum of the digits is divisible by 3. That's a cool fact, but it's not generalizable. If it doesn't work all the time, it doesn't work. You want to develop your students sound mathematically, where they can use one approach. I'll talk about efficiency in a second, but you want them to use as few approaches as possible to really master it. Mathematics is really a simple subject. We make it complex. Principle number 6, be efficient. You only need to teach addition one time. In our curriculum, the main principle of addition, you can only add the same things. When you add the same things, you get the same things. So, I put an example here, 3x plus 5x, pretty simple example, right? It doesn't matter what the coefficient is. I better see an x though, because if I'm adding x's, I better get an x. I shouldn't see an x squared. That confusion shouldn't ever enter the picture, because the only things you can add are the same things. So if that was 3x squared plus 5x squared, I should get x squared in my answer. You want to eliminate those typical errors that students make by creating simple laws and rules throughout your curriculum. Principle number 7, think ahead and be consistent. So here on my left and my right, I have 2 problems that I want to simplify. The word reduce, when we're talking about fractions, is a forbidden word in our curriculum. That's another conversation for another time. But look at these. They look like 2 totally different problems, right? But they aren't. I'm asking you to simplify 2 fractions. The first step is to factor the numerator, factor the denominator. Both fractions are the same. Then you remove any unnecessary ones, and you arrive at the final answer. It's the same process. So when you're teaching fractions in arithmetic, you should have algebraic fractions in mind. Therefore, you should be teaching from an advanced perspective. Number 8, explore wrong answers. This is lots of fun, and you'll see my esteemed colleague do this. He's a master at this. The journey is far more important than the destination. You want to build a community of thinkers in your classroom. This also gives kids the courage to participate even if they're not the strongest mathematically. This builds confidence. This builds community. That's important. Number 9, allow kids to teach kids. Again, this is all about confidence building. This is all about community building. Teaching is the highest form of learning. If you can teach it to someone else, that means you've mastered it. Give your children that opportunity as much as you can. Instead of there being 1 expert in the room, consider there to be 30 experts in the room, 40 experts in the room. Treat your kids like colleagues. Because guess what? The culture that you build inside of the classroom will spill outside of the classroom. And you'll find kids studying together. You'll find kids showing up to after-school tutoring, bringing a friend. These things are all important to the development of a child, and some of these don't necessarily always apply to mathematics. And finally, master your craft. I put master in quotation marks because there's no such thing as mastering teaching. If you feel like you've reached the pinnacle of teaching, please retire. We have a young up-and-coming lecturer in our department. He's a phenomenal instructor. And he's young. And I remember he approached my esteemed colleague, Lynn Bohm here, who's been teaching for 83 years, is it? And he says, you know, I'm pretty close. I'm catching up with you. Now, Lynn Bohm is probably the greatest lecturer in the history of Wayne State University, and I'm not just saying that. He's the real deal. And his reply was, that's impossible. So the younger lecturer says, why? He says, because I'm still learning. Find a mentor. Mentor others. Observe others. Critique one another. All of that is important to the process. Study mathematics. There was a time in my life with every mathematics book that I owned, I had solved every single problem in every math book that I owned. Make a commitment to your field of study, to what you're teaching. Make a lifelong commitment to mathematics. And one day it may take you around the world, as I stand before you right here today. But I put the first one up there, but I want to just end it with that. What's good for your children at home must be good for your children in your classroom. If you don't love these children like they're your own children, they won't have a chance. They won't have a chance. Thank you. That concludes this portion of my presentation. Are there any questions? I have a question here.
Good day. Thank you for your presentation. You talked about representing math in mathematical, in numbers. Mm-hmm. For example, pizza, not fraction is not pizza slices.
Yeah.
Can you go into that a little more?
Well, oftentimes, and again, that's tricky because, you know, in grade school, we tend to use manipulatives and things like that to represent. But over the course of years throughout curriculum, if you read lots of textbooks, different textbooks, especially, I encourage all of you, take about 5 textbooks, 5 math textbooks, arithmetic textbooks, and look at how they teach fractions. Look how they teach fractions. So over time, what's happened is that we've gone from showing kids how to represent what 2/3 may mean using a slice of pie or a glass of water, to that actually being the focus of the curriculum. So when I say keep it mathematical, what I'm saying is that you want to introduce fractions as numbers, and all of the operations apply. Now, if you want to get a sense and a feel of what 2/3 may mean, then you can start introducing some of those real world contexts. But at the introduction, it should be mathematical. Does that answer your question? Any level in mind, and most of those don't translate. That's the first thing. The second thing is most tricks are shortcut because we work in a base 10 number system. They only apply to certain numbers. So if it's not generalizable, what you'll have is kids assuming that the sum of digits if the sum of the digits are divisible by 4, then that number is divisible by 4 because it works for 3, right? So that's the danger in it. So shortcuts potentially, not all of the time, lead to long-term confusion. And we want to eliminate as much of that as possible on the front end because that's where those holes and gaps in understanding are created. What you want to do, a more powerful thing to do, is to allow your kids to recognize the shortcuts. Like, oh, wait a minute. Actually, if I did this and this, and that's more powerful than you actually teaching them a shortcut without them knowing and really fully developing their conceptual understanding on that particular topic. Does that make sense? Yes.
Exploring wrong answers. Did you have any example in mind, and how do you go about it?
Exploring wrong answers?
Did you have any example in mind?
Actually, my esteemed colleague here, he's going to be doing a demonstration in just a few minutes on how to do that, and he'll also be doing it with a group of kids on tomorrow. So if you're around for the entire conference, you'll be able to see that live in action.
Thank you.
Yep.
All right. In Ghana here, we teach normally from known to unknown. So if we are not bringing the pies, the glass of water that the child normally share at home, how do you now teach using just numbers?
Say it one more time.
In Ghana,
okay,
we normally teach from what the child does, what he does at home every day. For instance, with a fraction.
Oh, I see.
Sharing.
I see.
They normally share things at home. So you want to bring focus their mind that it's the same thing we're coming to do in the class, but this time we're going to use numbers. So if you don't relate it immediately from the onstart, it confuses them. So maybe how to start?
Very good question. That's a question that I won't try to unpack here. I should have started with a disclaimer that my presentation probably didn't have a Ghanaian context to it, but I'll be around for a few days, and I've already talked to Professor Dankwa. I would like to come back and conduct workshops and really introduce you to our curriculum. It's called Algebra Plain and Simple. That was written by one of our the founder of the math course, Steve Kahn. But that's a great question, and that's something that we could address. But absolutely, when you're talking about the context in the area and the children in the classroom, all of that must be taken into account. So thank you for that, and let's talk after this if we can. Okay? Yes.
My question is a bit directed to his question. I'm more concerned about the nursery because most times the foundations are not well laid in the nursery classes. So in relation to what he was saying, we're told like for the nursery, you start from the concrete to pictorial to abstract, which is the numbers. So for the nursery, where you lay the foundation for all the other topics, how do you now teach without making the children, how do you do away with the pizza?
That's a great question. And again, I don't have time to unpack our entire curriculum, but actually, I'll see if we can get you all copies of textbooks. We'll work on that. And we'll be putting this, I'll get you some of our curriculum materials. We'll see if we can get you all a textbook. And also, we'll be putting a series of instructional videos online that will be made available to all conference participants. But that's something I would like to discuss one-on-one, even though I know others have that question. But over the next 3 days, we should be able to address some of that during some of our other more intimate presentations. Okay, so now I'm going to show a 3-minute video. One more question back there in the back. And you have a question? Okay. Contribution. Okay.
All right, my name is Ben. In fact, the shortcut and the tricks you are talking about is part of our curriculum. Because the reason why I'm saying this is I teach students who are going to teach children mathematics at the basic level. And in one of our course books written by scholars or lecturers at UCC, University of Cape Coast, it is stated clearly there, divisibility rules. And I'm teaching people or students to go and teach the children. And even last semester, I taught that course. And if you are saying it's going to create problems for us, then it means we have to act fast. Yes, we have to. Because they are also going to carry it out. And there are more in the system who have started teaching that.
No. To answer that question, a lot of that, honestly, and I'll be as candid as possible, a lot of that is what's contributing to the bad trends. It's bad curriculum. That needs to be fixed. The visibility rules are developed in number theory. Number theory is a 5,000 level course at my university that's taken by graduate students. Those shouldn't be taught to kids as shortcuts. That's something that's developed in advanced mathematics. So again, curriculum and the way that we teach is the problem. It's not the teachers and it's not the kids. And so that's something that, again, we'll be trying to work with CEMATHS to address here in Ghana.
My name is Pearl Rosemary Coker, coming from the Central Region, precisely Abakrampa Senior High School in the AAK district. Yes, I had to interact with other people from other countries. I also learned new methods and new ways, proper ways of teaching the mathematics in order to take away the phobia out of my students. I've also enjoyed some of the pictorial lessons, and I've also been able to, I've discovered more better ways of teaching. I think that's all what I have.
University level students, with teachers like yourselves supervising the process so that we don't have to carry the load all by ourselves. We take on teachers are not magicians. We take on too much, but we have enough brilliance in each classroom to be able to enable and empower our students to do more. And that's what we're about. Now, we have reached a place in today's program that I'm so excited about. We're going to do something that is called a fish bowl. Fish bowl. Fish bowl. Fish inside a bowl. If you see a fish bowl, generally, it is a transparent glass, and you see what's inside of it. So inside a fish bowl, we find what? Fish, water, what else? Pebbles, stones, etc. So even though the fish are inside the bowl living their lives, you can see what's inside of it. And teaching, to a large extent, is invisible. When you teach, in fact, you're all teachers, so you know. Sometimes you make decisions on the fly. You see that as you're talking, I notice some ladies are talking, so I just ask a question and then I move on. The whole class, why I called on student X or student Y. Sometimes I move to a particular place in the classroom as I speak, maybe to control something. I don't say anything. So teaching, if you're watching it, is incredibly invisible. And skilled teachers have a way of unpacking teaching in a way that some of these invisibilities become visible, so that they can be meta or step out of a teaching performance and say, did you notice that? And tell you what they did and why they did it. So that somebody who is learning to become a teacher has a window into the mind of expert teaching. So our fishbowl session today, we are honored to have the Minister of Human to have Leonard here, Mr. Boehm. He's going to teach about 8, or I think we have 8 or 9 quote-unquote students in the math core way. The so-called students are just people who are one of us. Now what we're going to do is we're going to calmly observe everything he does, and then when he finishes, he's going to sit with them and we can ask him questions about the choices he made. Now, the thing with fish bowls is that when the fish are inside swimming, you don't go in and say, why did you swing left? Or why did you swing right? In fact, to a large extent, unless you go and tap on the glass, they don't even know you exist. So it is really important that as Mr. Boehm and his class are having their math moments, we quietly observe and are not intrusive, so that we can carefully take notes of things you notice and then bring it to his attention at the end of the teaching period. Again, we are not going to be interrupting. If you feel like laughing, swallow it. They can laugh? Okay, you can laugh. Okay? But it's really important that we preserve the teaching learning environment. Is almost like a lab, and we're watching teaching performance play out. So today we have the opportunity to learn from a master. If you see him teach, you just love teaching. Incredible. So I'm talking too much. Let's rather use the time to learn. Amen. So Leonard.
Okay. Oh, testing. Okay, before we do it, I'd like to give you guys some insights about what you might be looking for, and our volunteers, after I explain a few things, will come up, and I'll try to do my best to give kind of a mock lesson so that some of the techniques or philosophies that I mentioned briefly, hopefully I can demonstrate them. Now, I'm hopeful that how many people in the room teach really young students, like first, second kindergarten? Anybody? Okay, so my fervent hope is that when you guys leave, everybody, at least a couple of things that you can use tomorrow in your classroom that are pretty easy to implement. But very quickly, I'm the ice cream guy. What that means is the classes I teach are called discovery classes. So who's a brave person that would like to address all of us? What does it mean to teach by discovery?
Collins Sakite Osei is my name. I have actually learned a lot. Most of the African teachers see the children we teach to be tabula rasas, kind of empty slates for us to just go and pour the knowledge on them. But this conference has actually exposed me to different strategies to see the students as my focus and rather give them the opportunity to explore, to discover a lot of mathematics for themselves.
That the students on their own discover the mathematics. Now, a lot of instruction starts at the so-called lecture, and all of us will lecture at times. And when we lecture, we're just telling kids, we're giving them information. Discovery, the kids are discovering things on their own terms. So in the math core, our so-called discovery classes are taught in a Socratic way. That just means we teach by asking questions. And the fanatic Socratic teachers like myself teach 100% by questions, except for a few jokes now and then. Okay. Jokes are hard to tell Socratically. But also in our discovery classes, the students discover higher level conceptual mathematics. So for example, our 7th graders, 12-year-old students, learn topics from calculus. I think I mentioned in the earliest session last summer we investigated some topics in infinite series, which I taught at the university, to an honors calculus 2 class, the exact same problems. In our senior classes, some of the topics that they explore are transfinite set theory, where our students discover 2 of the 5 greatest theorems in all mathematics, which most math majors don't know about until they go to graduate school. The point being that our students are capable of that type of thinking. So rather than spend a lot of time, because we are short on time, the 3rd level of teaching is what we call the group discovery teaching. You can sit at a blackboard and explain something to students, or you can walk around the class and ask your students questions. Or you can ask questions where not one student responds, but many students respond. And that way, you can keep all of your students involved. If I'm teaching a class and I'm noticing I'm getting 4 or 5 hands up and maybe 30 kids are kind of sitting passively, I will flip and ask a question where every single student in that class has to respond at the exact same time. And I can see who's not responding and who is responding. So there's techniques that we've developed that allow you to ask questions where every single student in the class will respond. And if you get trained, you can look very quickly throughout the class, and you can spot maybe a student who's not responding. And then, boom, I'm going to get that kid. I'm going to make sure he gets some nourishment from me. Now, the student might be dealing with some issue. Who knows? He might not be feeling well. She might not be feeling well. She may be lost. So I may or may not ask a question individually. If I think the student can answer it, I'll cold call her or him. If I think the students there's something going on, I ask a question, I'm moving through the class, and I'll do something like this. You feeling okay? You all right? Okay, cool. The point being that for me, a successful class, if I walk out of a classroom and I can honestly say 30, 35 kids, if every single student got a morsel of nourishment that day, that's a successful class. If somehow we did something where that student realized his greatness, that we cared, that's a successful day. But that's not easy. It's ideal. So one thing that I do every day after I teach a class, I'll sit down and I'll look at my 30, 35 students, sometimes 40, and say, okay, who was absent? Make a list. Who did not participate? Who didn't I communicate with? I make a list. So there might be, say, 5 students. When I walk in the next day, I am sure I'm going to get those 5 kids. I'm going to give them a hug. It might not be a physical hug, but it'll be a hug. And the power in that is if you spend that time thinking about those kids that aren't responding, that frees your mind up. You're already thinking when you walk into that classroom about the rest of the kids. You're sensitized. You're looking for that. Now, I could go on for like 3 weeks of talking about this stuff. So what I'd like to do is actually attempt to teach a mini lesson. So, before we go up, we have some signals. They're feedback signals, and you probably saw some of them in the video. Now, these are the things that everybody in this room, independent of your subject matter, independent of your grade level. I've seen these signals work. I taught a demo for a 5th grade kindergarten class, and I teach seniors in high school, and these signals work across the board if they're applied in the right way. So the first signal, these are feedback signals so that I can tell all along who is with me, who's not with me. So the first signal is this. It's our agreement signal. If I make a statement or a student makes a statement, I'll say, hey kids, show me with your signals. And it goes like this. Could everybody go like this? But now, if you disagree, then the disagreement signal is like this. So let's practice these signals. Mr. Bohm has a beard. I don't see any signals back there. All right. Mr. Bohm has had a beard for the last 10 years. Well, some people know me. I don't know. We are presently in Accra, Ghana. And tomorrow, we'll take a super plane. We'll be in Detroit, Michigan, where it's probably below 0. No, don't like that. Now, we do have more than just those two signals. Those are the two basic. But another signal that's maybe the most important of all, and I see Cynthia doing it up front. So, Cynthia, would you like to very quickly, we had the honor and the pleasure of having Cynthia's with our camp. She volunteered as a grade supervisor. Could you please explain to the audience what that signal means?
Okay, so that signal basically is to support someone, perhaps someone trying to give an answer to a question or make a contribution. Sometimes you see those kids, they're trying to say something and it's as if they are not sure, but then when you keep doing this signal, they feel like the whole class is supporting them non-verbally, and it's really very encouraging. Thank you.
Very good. Is that for her or for me? I think it's for you. Pregnant men don't get too many supports. And actually, that signal was invented by a student, oddly enough. Years and years ago, some student was going like this naturally. So what's going on? I'm supporting him. And one of the most striking examples of that was years ago, our kids were giving this is pre-math corps, by the way, but they were a little girl, she's 4th grade student. So she's like 10 years old, 9 years old. And we're in an auditorium, 2,000 people filled. Spotlights at night. Her classmates were sitting in front of her. There was like 10 or 12 classes. It was big, and the parents were sitting in back. And she's standing up at the edge of the auditorium, and you could not see because of lights. And she starts to recite this poem, and she kind of loses it under the pressure. And then she looks down, and she sees about 500 kids going like that. So this is a very, very powerful signal. And again, I could spend an hour talking about how you implement that, how you nourish it. But it's a very simple thing to implement, and then when students do it. So let's say someone says something and there's some support, you simply say, wow, I love the way so-and-so is supporting, or great job of supporting. So in the interest of time, what I would like to do, oh, by the way, we have some students coming from the village of Hope Orphanage tomorrow, and I'm going to attempt to teach a lesson that will, basically the same lesson, that will hopefully explain these techniques in real time. But I'm going to need your support, because I'm afraid of two things. Afraid's not the word. One is I tend to talk fast, and I'm a little worried the kids may not understand part of my questions. And the other concern is they might be very, very shy and won't respond. And normally, we're working with 30, 35 kids. There's a lot of energy. So with the low number of students, then the energy drops. So I will need your support tomorrow. So right now, could our volunteers please enter the stage, and everybody can get as close as they want. And I'll try to do a mock lesson. Think about a couple things. What techniques are being used? How are the questions being asked? And then we can maybe, if we have time, talk about the power of discovery teaching. Okay. Is that my students? So guys, this is the first day of class. You've never seen me before. I walk in the classroom and I'll say, "Good morning, team." I can't hear you. Come on. Okay, guys. So, if I write my name on the board, could one person pronounce that for me, please? I need a pronouncer. Give it a try, Abed. Do your best.
Mr. Board.
Fantastic. That was absolutely perfect. Give me a high five. When my hand touches the board, gang, would everybody say my name? Ready, set, go.
Mr. Board.
Okay, wait. When my hand touches the board, not before, not after.
Mr. Board.
Okay, beautiful. And now, guys, we're going to study some things maybe you haven't seen before, but in order for us to move fast, I need to know what you're thinking. So when I say go, could you give me the agreement signal? And the agreement signal just looks like this. Could everybody do that for me? Okay, let's practice this today. You guys live in a car. I say yes, yes, or no. I need signals, like you can't tell. Oh, well, see, I already messed up. Because I forgot something. See, I'm nervous. You guys have to support me. All right, thank you. Sorry, kids. We also have a disagreement signal. So, the demon brother. If somebody says something and you disagree, could you please go like this? So now let's try these signals. You live in a crop. Show me with your signals. Oh, I see. Almost total disagreement, but some disagreement. Very, very good. And let's see, today is, show me with your signals. Is today Thursday? I see disagreement from Esther. I see disagreement from Emmanuel. Very good. So, thank you. And there's one more signal. If somebody says something in our class and you want to support them, would you please go like this? Everybody. That means keep on going, I support you. Okay, gang, now I'm going to have to hold the mic right and talk at the same time. Fortunately, I'm not chewing gum. So kids, we need a brave student to spell the word summation. Who would like to try that? Summation. Okay, kids, get your support set for Esther. Esther, would you please?
Summation. SUMMATION.
Bing, bing, bubba, bing, bling, bling. Kids, show me if you support Esther or not.
I'm Benetta Frempon, a student of Accra College of Education, a level 200 student. Well, before today, I thought teaching maths would be very difficult, if not impossible, for someone like me, because females are not really into mathematics. But then today's workshop has enlightened me to know that mathematics is not different from any other subject. Unless you put your mind to it, you can do it. So that's what CEMATHS has done for me today.
Need another brave person to read this symbol just like I wrote it. Just read it like this. I'm going to go, Abed, just read that for me, please. And gang, please support Abed. Abed, take it away. Do the mic, please.
Summation.
I'm looking for signals. Agreement, disagreement. Okay, I see great signals. Hey, in fact, let me make that team to the power of 1. Everybody agreeing with Abed. Now, when we do a summation problem, there's 3 invisible words. The first invisible word is from. So we now need a brave person to read what I have on the board now. Just follow my finger. Molly, can I put you on the spot? Okay, grab the mic and just read as I point. Ready, set, go.
Summation from. Okay, I is equal to 1.
Perfecto mundo. All right, I only see the signals. Come on, guys, show me what you think. Now I see some strong support, some agreement. Now, gang, the second invisible word is 2. And I'm going to make, in fact, can somebody tell me what's the third smallest prime number? The third smallest prime number. Somebody take a guess. Esther, what do you think?
3.
That is a fantastic guess. Give me a high five. That's beautiful. That happens to be the second smallest prime number. But now, who knows the third smallest prime number? Let's go. Guys, let's get our quiet support for Abed.
5.
5. Okay. Now, can I have the whole class read what we have? Can I have the whole class read what we have right now? As one voice. Ready, set, go.
Summation from I equal to 1 to 5.
Perfect. Perfect. Team to the power of 2. But now, there's one more invisible word, and that's of. So, who would like to read the first summation problem of the day? I need a brave person. Emmanuel is a brave person. Could everybody in the audience please give your support for Emmanuel? Emmanuel, see that support? They got your back. Take it away. Follow my finger.
Summation from I equal to 1 to 5 from of I.
That's a great job of reading my scribble, and I see strong support from my colleague, Mr. Gardner. Okay, now, guys, let's go for a team star. Could everybody sit up straight and read this summation problem as one voice? Follow my finger. Ready, set, go.
Summation from I equal to 1 to 5 of I.
Great job, gang. In fact, that sounded like one voice, team to the power of 3. Now, who is a brave person that wants to take a guess? What number does a summation from I equals 1 to 5 of I equal? I need a brave person to just make a guess. Just make a guess. Okay, Abed, grab the microphone. And Abed, what do you think it's equal to?
13.
30.
13. 1,
13.
3.
13. Let me think. Let me think for a second. Abed, that's a great guess. You have given us a lower bound. The number I'm looking for is larger than Abed's 13. Who else would like to take a guess? A number greater than 13. All right, guys, would everybody get your signals? Audience and students for Emmanuel. Speak of the mic. Emmanuel, what do you think it might equal?
15.
15. Emmanuel, that was a terrible guess because the answer is exactly 15. So gang, would you take about 2 seconds in your notes, write down that first equation as quickly as you can. Easy? Okay. Okay. So everybody's writing fast. Would you please sit up straight and let's read this together as one voice. Ready? Set, go.
Summation from I is equal to 1 to 5 of I is equal to 15.
Perfect, perfect. Let's do another summation problem in a hurry. What if I used the same lower limit and changed the upper limit to 6? Who would like to read that problem very quickly for us? I need a reader. Andrews, you want to try it? We'll support you. Okay, guys, I put Andrews on the spot. Let's support him. Andrews, take it away.
Summation from I is equal to 1 to 6 of I is equal to.
Wow. So let me see a show of hands. How many students right now think they see the secret, the definition of summations? Raise your hand if you think you see the secret. Oh, Abed and Emmanuel. Esther? Well, who thinks they don't see the secret that would like to take a guess? What do you think the summation from I equals 1 to 6 of I is equal to? Sabraj, just take a guess. We will support you.
18.
18? Wow. Emmanuel, is that what you were thinking? 18. Were you thinking 18? 16? Yeah. Well, Chadwick, I see some nice signals from the audience, but that, everybody, that was a very intelligent guess. Very intelligent guess. 16 is bigger than 15. Oh, wait a minute. I will give somebody a star. This was not only an intelligent guess, this was a brilliant guess. But who can explain it? Who sees it? Okay, guys, would everybody get your support set for Abed? And Abed, would you address, in fact, before you say, just say my esteemed colleagues. That means you're talking to all of us. So, my esteemed colleagues, all of us here, and visitors. All right, guys, let us support Abed.
Okay, my esteemed colleagues.
May I ask a question first? I'm sorry. Do you agree with Shadrach's answer?
I don't agree, but I know how he had his answer.
Okay. Would you please explain that to everybody?
My esteemed colleagues and visitors. So looking at the first equation, the summation from I equals to 1 to 5 of I. So there is 1 and there's 5. So 1 adding a 5 to it will give you 15. So coming down to the second equation, summation from I from 1 to 6 of I. So 1 Attaching the 6 to it gives you also 16.
Okay. Now, in fact, let me ask another question. Pencils down. Pencils down. This is such an interesting idea. Suppose I did this problem. The summation from I equals 1 to 9. Who could come to the board and use Shadrach's system to write down the answer to this problem? What would that be? Oh, let's go with Wally. Can you do it? Come to the board. And also explain it. And guys, would you please support Ollie as he comes? And look at that support from the audience. And when he turns around, gang, would you show him agreement or disagreement? And what do you see? Support. I see strong signals from the back of the room. I see strong signals from Esther. Nicely done. Okay. But now, wow. It's clear that we have some potential mathematics in the crowd, and I'm not talking about you guys. Now the question remains, these are brilliant systems, but does anybody have another idea what this second summation would equal? Go for it if you think you know. All right, Abid, what do you think? This is 21. Another terrible guess, because it's absolutely correct. Okay, gang, let's read this second result together. Ready, set, go. Wait, excuse me, I'm sorry. Let's have the whole audience read if you can see the scribble to support our students. Okay, guys, take it away with my finger. Ready, set, go.
Summation from I equals 1 to 6 of I equals to 21.
Beautiful, terrific, fantastic. But let me count hands. How many people see the secret of summations now? Abed. Okay, let's try another problem. In fact, kids, would you show me on your fingers, what do you think the next upper limit should be? Make that number on your fingers real high. Okay, bad question. Guys, when my finger touches the board, tell me what I'm pointing to. The first upper limit is, come on, you're late. You got to say it when it touches the board, not 2 seconds afterwards, so be sharp. The upper limit is?
One touch here.
5. Aha! I can fool you once, but I can't fool you twice. When my finger touches the board, what do you think the second upper limit's going to be? Everybody. 6. So show me on your fingers, what do you think the next upper limit should be? Up real high. Show me on your fingers. I see 7 from Andrew, I see 7 from Abed, from Shadow, I see nothing from the audience. Now I see some 7s. Very good. So, could everybody, including the members in the audience that can see the board, read the third problem? Ready, set, go.
Summation from I equals 1 to 7 of I equals to.
Could I see signals? Yes or no? Who believes the summation from I equals 1 to 7 of I is less than 15? Agreement or disagreement? I don't see signals. Oh. Who thinks it's less than 15? Who thinks it's greater than 15? Esther, what do you think? You think this will be greater than 15, or less than 15, or greater than 15? Greater. Who thinks it'll be greater than 21? So who thinks they know the secret? In fact, who wants to take a guess? Shadrach, what do you think?
28.
20.
28.
28.
So first of all, you can't give something you do not have. So my methodology for going to teach mathematics is that people usually learn from those they like. So if you like mathematics, if you make your students like you, they are going to like the subject and it's going to be very simple for them. So that is what I'm taking away today.